Okay, so JH304, this is Wednesday, 18 February, 12:43 p.m. Okay, so this is a lesson on topic 3, part 3. Okay, what are the general shapes of log graph? We are going to look at it today, and then also the key properties. Okay, so if you don't mind, some parts I will go a bit faster, some parts I will tell you important then just take note. Okay, what are the log graphs applied to real world problems, and how do we go about solving them? So log graph, a function, is a function of the form y equals to log a power x. Now if you remember from part 1, part 2, I just want to bring your attention, a and x have to be positive. At the same time, a cannot be 1. The growth rate cannot be 1. But can y value, example, can this be negative? Can. This can be negative. Okay, what is this for? This is often a basis for rejecting answers. Okay, this is often a basis for rejecting answers. So you do topic 3, part 2, you realize, how come Mr. Tan marked me some wrong? How come? Because you need to reject some answers. They defy this outline. Right? You get x is negative 2 based on this cannot take. Okay. Now we look at the natural log. The natural log is the function fx equals to log. Fx basically is function. If you don't like fx, you can call it y equals to log x. It's the same. It's the same. Log is the same as log base e. Right? Typically, when we write it log base e, it doesn't look so sexy. So we write log. Log is nice, cool. Right? Okay? Just like Sean Tam, I call him ST. Caden, I call him KF, for example. Okay? Water bottle, sure. Okay. Can So from here, just everything you have seen before. Now I want to show you the graph. Okay? Now using a graphic software, I sketch the graph of log 2, log 3, log 5. 1/3, half, and 2/3. Now in the interest of time, I'll show you what the graph look like. Okay, so some features about the graph. Okay, Alex, head up. Yeah, sit up straight. Okay. Kang Yu will slap you if you keep. Okay. Now you see x equals to 0. X equals to 0, this is the asymptote. Okay, this is the asymptote. Okay. Basically because when you take log ax, right, can this be 0? Try pressing log 0, cannot. It has to be positive. That's why x has to be, you can see it cannot be negative. It's always on the positive side. Okay? Now if you sub x equals to 1, log a1 is 0, right? That's why it's 1, 0 here. Okay, so these are the features. X equal to 0, 1, 0. The third mark is also the shape. What is not so important, not say not important, but not so crucial in the near future. You don't need to go and consider different bases. You don't need to consider different bases on the same graph. You just need to know the shape. Okay? Now what shape is this? How to remember? Look at. So you look at your right hand. Right hand, right hand. Okay, my art is always jialat. My art is, I've never passed art in my life. Okay. So you remember, this is the right hand. Right hand with the middle finger facing upwards. Sorry? Okay. Did I put the L? Yeah. Oh! Because you took the L. Oh. Just kidding. Thank you, Joshua. Okay. Love you. Okay. So okay, so this one is blue color. What is this, Joshua? Do you remember what's blue color like? Right here. What does it stand for? Is it your money line? Never mind, it's so short. Okay. So honestly, math, in terms of math, y equals to? AX, where? A is not equal to 1. There's more than 1 and less than 1. Is this more than 1 or less than 1? More than 1. Okay. So what is this? This is y equals to log ax, where a is between, A is more than 1. You realize? So your hand can tell you so many things. Oh? Okay, ah? Can ah? So it's here, okay? Over here. Over here. This is the red one. This is the blue one. Okay? Right hand, your right hand. Okay, a simple way to remember lah. Okay, it's stupid, but don't you agree? Sometimes stupid things then we remember better. Right or not? In math, we remember stupid things very fast, right? But when Mr. Tan start to talk serious things, everyone falls asleep. Okay. So it's like that lah, huh? Yeah, this is A part. Okay, so this is log. Okay. Okay, do you all need to copy? Okay, maybe I pause a while. You all copy first. Okay, you need to draw the y-axis. But the crossover is okay. Works. Yeah. Works. That's a strategy as well. Sometimes I draw the axis last. That's a strategy as well. Anyone stuck anywhere? Xingyu okay? Zekai okay? Zekai, Kaden yesterday, Zekai and Zhisan yesterday we went through the topic 2. Salihan also went through topic 2, practice set 2 and assignment. Yeah, I will try to make video and send you. Yeah, very nice. Looks so pretty, just like you. Or not? Archie, show me, can? Archie, show me. Wow, Archie, you all look like seaweed, eh? Come to so close together. Okay. So I say again, okay, if you didn't draw so nice this time round, it's okay. Wow, Jianing one very nice, so handsome, just like you. Okay, can Okay, so what do you know? Okay, guys, I say again. Do you need more time? Okay, I'll wait a while more. As you are drawing, I will keep talking. Can I'll keep talking just to keep reinforcing the certain points. Okay, again, you don't drawing different bases on the same graph. Not so important this time. But you do need to know that this is the shape. Okay, meaning example, I ask you to draw ln x, but I will not ask you to draw log 2 base 2 base 3 base 4 on the same graph. Maybe not this time round. What do you mean? I slap you, what do you mean? Okay. Huh? Yes, Salihan? Okay, okay, then this one also same, it cannot touch. Okay. Hey, you need to draw the right one. What are you doing? Aiyo. Then you need to label. Where's your y-axis? Where's your x-axis? Not done, then you still yaya papaya like that. Huh? You see Hashini slogging away, you cannot, something wrong, right? You sit there, you like datuk like that. Okay. So, what do you realize? Okay, the graph is only defined for x more than 0. Okay, for x more than 0. Now, it always cuts at 1, 0. Why? Because when x equals to 1, y equals to 0. Make sense? Right? So if I look at this, right? Guys, you look at this, right? Right? If I take y equals to log 3 of 1, what's log a of 1? It's always 0. That's why you can see that this point is 1, 0. When x equals to 1, y is 0. Okay, the solution is always x equals to 1. You notice that here, as x goes to infinity, okay, wait, you can see, as x goes to 0, y goes towards negative infinity. Here, look carefully, notice how x gets smaller and smaller. X is going towards 0. X tends to 0 over here. What happened to the y value? As x gets smaller, the y value is getting towards negative infinity. That's what they mean. When x gets smaller and smaller, y goes towards negative infinity. Over on this right, as x gets smaller and smaller, Joshua, y goes toward? Very good. Okay, Xingyu. As x goes towards 0, Y goes to what? Very good. Isabella, Wu Tian. Choose a person. Zhisan. As x goes towards 0, y goes toward negative infinity. Okay, can make sure you all know how to describe the graph. Okay? They will ask you to write words sometime. Okay? So these are the, again, you can see that compared to exponential graph, where x-axis is the asymptote, log graph, the y-axis is the asymptote. Okay? A vertical asymptote. Okay? So remember, you need to label your graph. What is the intercept of 1, 0? Okay, so if you start x equals to 1, right now, y equals to log 3. Remember, this is the function. Log 3 of 1 is always equals to 0. Okay, that's why it's 1, 0. Okay? Can Okay, so I will show you what I expect from notes. Okay, you look at this one. Wow, look at look at this graph. Okay? Your notes should be of this standard. Okay, look at this. Ayo. What's the Malay word for it? Cantik, correct? Pretty, this is very pretty. The graphs, okay? Like that easy to study. Okay, you don't put in effort in your notes, then you will like to see. You will look palatable. Some of the notes, the boys draw, look like come out from the Vietnam War like that. Okay. You see this one? The notes come out already. Walao, Jia Kai. Oh my God, you. Okay, so you still so proud to say. Okay, so I go down. Okay, now using this. Okay, now what I want to sell to you, what I want to bring to your attention is this. Okay, if you look at y power x, ex, and ln x. Okay, the thing is they are actually reflections of each other about the line y equals to x. So you see carefully, okay, there's a mistake in the graph. E power x is here. E power x, y equals to x, and ln x. Okay? Do you see that the graph are actually reflected about the middle line? Do you all see? You all see? You all see? This is the middle line. It's like the Chinese chuan like that. Okay, this is the middle. They are reflected about the line y equals to x. You cannot just say symmetrical. You cannot just say they are reflected. You must say reflected about y equals to x. Reflection must come with a line of reference. Am I reflecting about x equals 0? Am I reflecting about y equals to 0? Am I reflecting about y equals to x? Okay? Yeah. Previous again. Okay, here. This one? Previous. You all managed to copy? No. Okay, so I stop here. No, the x-intercept is always 1. There will be no y-intercept. Okay, There will be no y-intercept. JH304. Okay, so can you see this graph is this shape? Y equals to log ax. Y equals to log ax. The base is more than 1. Can or cannot? Can, Okay, so now I turn my graph. Okay, now I turn my graph. Okay, now you see, I pretend I shake hand with you. I take my graph, I turn this way. Can you see? Now I look at this one. Can or not? What base is this? A more than 1 or less than 1? The 2/3 you tell me more than 1.
Less than 1. I thought it's the like something over.
You pay attention to me lah. Hold look at Emily. I know Emily pretty. Look at me, can or not? Jialat you. Okay, What you do, you party whole night, is it drunk, Okay. Can, Same here. Like this, base more than 1. Like this, base less than 1. Okay, Base more than 1, base less than 1. Can? Yeah, when you dance that time you. They do. You know the John Cena? Yeah. Okay. Yeah, I can't see you. When I'm marking, I cannot see your marks. Okay. Okay, can So here, this is the reflection. Okay, So e power x and ln x, they are reflection about each other. They are reflection about each other. Okay, They are reflection about each other. Y equals to ln x. Why is that so? It's because, in the sense, right? Okay, if you are interested to find out more, especially those who are very strong in math, okay, they are what we call inverse functions. Okay, they are what we call inverse function. So e power x and ln x, right? And also 2 power x and y equals to log 2 base 2x, they are what we call inverse function. Okay, they are what we call the okay, can They are what we call the inverse function. Okay, they are what we call the inverse function. Can So what are inverse function? Okay, you don't need to know at this point in time. Okay, you don't need to know at this point in time. Can You just need to know one thing. Okay, most of the time they test this, maybe not so recent, but in YEA. Okay, in YEA, right? E power x, ln x, they are reflection about each other. Okay, why is that so? It's because, okay, you see, okay, can I erase this? Maybe I just take a photo here. Take a photo, What here is this? Okay, so if you notice, right? Okay, maybe I can just write here. You notice, right? Okay, if you see, y equals to e power x. If you convert this, right, to change, it's the same as x ln y. Same thing, y equals to ln x is the same as x equals to e power y. Notice the relationship between the two functions. Can you see, like, in the sense, okay, then Zekai, can you see, like, in the sense the x and y swap place? Can you see that the x and y swap place? Y and x become x and y. Can you see? This is what I mean by inverse function. So if you are keen to know more, you go and study, go and read up on inverse function. X and y swap place, right? You can see, guys, the coordinate 0, 1. What does it happen? Become 1, 0. The x and y coordinate swap place. When the x and y coordinate swap place, right, that's how you get a very nice reflection across y equals to x. Okay, in real nature, there's a lot of beautiful features that follow this. Like, see the basketball, the line? Can you see? Curves, many curves that they use in engineering architecture. They have to, like, how do I come up with this curve? You need an equation. Okay? Can I? Oh, okay. So if you are okay, may I go on to the next one? You draw already not? You show me. You draw already not? You draw not, bro? Your page. See, draw. Yeah. Not like I become like a pastor already. Alamak, uncle, you just sitting in front of me. I talking the whole day. Then you never draw. Jia Kai. Yeah, very nice. Wow, I thought Hashini become like your grandmother already. Telling you, draw. Jia Kai, draw. You you're so lucky you got classmates like that, Cute you. Okay. What else is missing? Draw already. Can I go on? Am I allowed to go on? JH304. Okay. So I start. Okay, this question, do not touch each other. Okay. Yeah. Okay, now let's take a look at 3.2. 3.2 is pretty important. Now if I were you, I will start this question. Jia Kai, what did I say? I say Jia Kai. Okay, what did I say? I will start this question, I will do it 5 million times. Okay, I'll do it 5 million times. Okay, so do you all take geography? No. Whole class take history, right? But I think I'm sure you heard of earthquakes lah, huh? Earthquakes, right? Earthquakes. Not the Swensen that ice cream one, but the earthquake. Earthquake, remember when they talk about magnitudes, right? Magnitude 6, magnitude 6.3. Right now, those of you who have the Philippines, China, like I think there's always a lot of earthquakes. Japan, right? If you go to Japan, there's always a lot of earthquake. Oh, especially the volcanoes, right? So the if in case you do not know, the earthquake, how they measure is called the Richter scale. It's named after a guy named Charles Richter. Okay, so the measurement of the earthquake, in case you are wondering, magnitude 6.3, magnitude 6.4. In Chinese news, they say, 6.7级地震. Okay, so that means 6.7. The full scale is 10. The full scale is 10. But to get 10 is like earth shattering lah. Okay, so if you get magnitude 10, the full scale is 10, is like the tectonic plates really like go over each other. Right? So stop touching each other and pay attention. Joshua, why you never stop them? Okay, so the magnitude, right? Okay, listen, because I want you to listen. I want you to really see how I do this question. Alex, are you with me? Are you with me? What are you doing now? What did I say? What did I say? No matter how fast you are, you listen to me. Understand? You listen to me, because when I slow down, you must slow down with me. Okay? Because I got very important things to tell you. Okay, you haven't seen the question, Alex. You haven't seen the question till you see it through my eyes. Okay? Can So listen carefully. Magnitude. Now M is log I over S. I is intensity. Okay? So if they give you a very long question, S is basically, read the whole question, right? I is intensity. S is the intensity of a standard earthquake. Okay, now this question you go and do it many times. Earlier in the century, the earthquake in San Francisco registered 8.3. In another year, another earthquake was recorded in South America. There was 4 times the earthquake in San Francisco in terms of intensity. What was the magnitude in South America? Like I said, the full scale is 10. Full scale is 10. Okay? Okay, so you need to read carefully. Okay.
So the strength, the magnitude of the earthquake is actually exponential.
It's exponential. It's a logarithmic. Okay, so now, okay, you look at the first one. Okay, this 8.3 represents which letter? L? Where got I? M. Okay, on the Richter scale, we use M. M for magnitude. So this is saying that, okay, example, M1 is 8.3. Okay, M1 is 8.3. M1, for example, San Francisco, guys, the magnitude is 8.3. Right? It is the same as log I over S. Is that okay? Now, then in America, South America, I really want you all to pay attention to this question. This, in South America, second magnitude. What do you know about this? Can you tell me? I'm hearing something. Very good. It is 4i. So you replace this with 4i. Is that okay? Okay, you replace this with 4i. Alex, have you gotten an answer for this question?
Yes.
What's the answer?
8.9.
Okay, good. But I still want to stop and pay attention to me. Okay, can Yeah. Then after that, what do I do next? How do I find M2? Okay, is the I and the S the same? Is the I and the S the same?
Yeah.
Yes, it's the same. S is the, like the Avogadro constant. Okay, it's the intensity of a standard earthquake. Okay.
What is that value?
I do not know, but I do not need to know. Okay, I, just a normal intensity of the earthquake. Okay, now I know this is I and this is 4I. How do I evaluate this? Anyone? What can I do? Anyone? Alex, don't say, Who solved for you? Don't say. Okay. Anyone? How do I find log 4I over S? Okay, I'll give you an idea. What is log I over S? What's the value? What is log 4I over S? How do I find? Huh? Separate? What do you mean by separate? Oh! I don't know.
Is it log 4i?
Something like that, but I'm looking for a bit different. Any more? Anyone want to try? Xavier got something very close. What do I do? Janine? Not square root. Tyson? Renee? If I got for I over S, if I got I over S, how do I find this? Emily? You know? Want to try? Archie? Kate?
Is it just adding log 4?
How? What do you mean by adding log 4? Kaden? Yen? Yong Kai? How do I get from here to here? Anyone? What can I do? Huh? No, no power.
Log 4i equals to log I plus log 4.
Log 4I equals to... Okay. So I'm hearing splitting, right? Correct. Well done. Okay. Log 4, can I say it's the same as log 4 plus log I over S? What is log I over S? 8.9. Very good. So this is 8.9. 8.3. Very good. I'm testing you. Okay. Yes? Wait. Wait, now I'm writing. Yeah. Plus. This is log 4 times I over S. Okay, can So the answer is 8.9. Is it okay? Go and do this question 50 million times. Put a star. Okay, so put a star. Okay, Okay. Can? Oh, my battery is running out. Let's hope for the best. Do I have another iPad? Unless can Okay, children. Okay, no issue. Any issue? Everyone copy already? Yeah. Okay, I pause a while. Okay, so now I will come to question 3.3. Okay, which is the depreciation question. So we know that the value will eventually go on to zero, right? Because car is never investment. Once you buy, you drive out of the garage, immediately drop like $20,000. Okay, So this value here, right? Okay, basically, what's the original value of the car in V0? Okay, we read this as V0. V0 of V0. Basically, you see a kosong there, right? Zero, right? This really means that, okay, usually in physics or science, it means the original value. This means V when time is 0. Typically, 1. Means it's V0. We call it V0. V0. So now, the original value, right? This, right? Okay, you know the value of the car goes like that, right? This is the value. V0, E negative KT. This is the function. Sadhana. So, what is the original value? Okay, when you see original value, right, what comes to your mind? Shivani. Original. Sorry? The actual at the very first. Very first. What was time? 0. So when you see original, initial, starting point, time is 0. All these are trigger words for time is 0. Okay, so here you sub time as 0. What is V? You can see V is V0 times e power negative k times 0. What is k times 0? 0 lah. Okay, so what is V0 times e power 0? What? 1. V0 times 1. It's the same as V0 times 1, which is V0. So I'm trying to tell you that when time is 0, your value is equal to V0. You understand? V0 is the original value. 0. When time is 0, my value is V0. So straight away, guys, the answer for part A, the value is equal to V0. That's all. Very easy one. Very easy. Nice and easy. Okay? Can So I go to part B. Part B, they say I want to find the value of the constant K. How do I do that? Now, okay, so you can see there's another hint given to you. This hint here, see carefully. After 18 months, the value is 2/3. What does it mean? You read in English, you think in math.
2/3 times B0 equals B0 times e power negative k times 18.
Yeah. So let me finish. Okay, so basically this part, right? All you need to do is t equals to 18, the value is 2/3. Okay? The value is 2/3. Yeah, so I'm saying that at t equals to 18, the value is 2/3 of V0. Like what Joshua has said earlier. Okay? Why are you looking at the sky? Look at me. Okay? So now you sub into the equation, guys. You see, V0 e negative kt. Here, you sub this in. You sub t equals to 18, value is 2/3 V0. So that means you have 2/3 V0 equal V0 e negative 18k. From here, what can I do to the V0?
Cancel
I can cancel, right? Literally just cancel, Very good. I can just cancel. Then 2/3 is e negative 18k. Then what can I do? You see E, what will you do? I want to see someone who don't know the answer. Sadhana, what will I do? You see E, what will you do? Very good. You ln both sides, right? You ln. Right now, bro, that's the way, man. You see a ln, you see a E, you always ln. Okay? Why do you do that, Sadhana? Or why do you do that, Colin? Why did Sadhana do that? Colin, okay, why did Sadhana do that? When she see a E, she take ln. Why does she do that? Yes, you can cancel out. Okay, because I can bring down. And what is ln E, Colin? That's why, like you said, can cancel out. Ln 2/3 is negative 18k. How to find k? Very simple. Negative 1/18 ln 2/3. If I'm not wrong, the answer is 0.022. Oh, that means I tell you wrong. Sorry. No negative sign. I stupid. 0.00. Got 2 zeros. So I can calculate in my head. Just kidding. I saw the answer. Okay. So 0.022526. Okay. Scholars just take note. Intermediate steps in NJC, we always take 5 to 6 significant figure. Okay, 5 to 6. Final answer, we put 3SM. But we need to present this as intermediate. Can? We need to present this intermediate. Okay. Present this as intermediate. So you need to present both. Because sometimes you may use this for later. Save this for later. Use this for later. Okay, sometimes you may use this for later. So just take note. Can? Okay. Yeah. by the power law, right? By the power law, you can bring the negative 18k forward. Then 19k times ln E is just 1. Negative 1. Huh? So I go to C part 1. What do I do? Very simple. You suck in 3, 4, 0, and 7. Right? C part 1. This is your equation. V0 E negative 0.000222526 times k. Right? Now you sub time as 7. Is it 7? 7, right? Time as 7 and the value is 340. Okay? So yes? Did I make a mistake? Thank you, dear. Okay. So this is time. Okay? So what do you want to find here? We want to find? D log. Okay, so make sure you understand this. Right? The V0 is 398,000 because I substitute 7 and 340. 0.0, sorry, 0.0, my bad. Yeah, 0.0, okay, 0.022526, okay, so that's part 1. Joshua, okay? Huh? Confused over B? Yeah, what about this? Can I bring this power to the front? Then ln E is just 1. Can Then I divide this by negative 18. I can find my K already. Just some, math is like that. Like I would massage the terms a bit, then bring the terms around. Yeah, because I want to find K, man. I want to find K. Okay. So that's part 1. So part 2, okay, so you see, I was going through that day, what will happen? The graph will go to 0. Again, you see, the graph will go to 0, but it will not touch 0. Hey, uncle, I already at part C, you still at part B. You got copy or not? Okay. 专心 focus. You must do this for her. She cannot be helping you all the time. She also need to focus on her. You need to pay attention. No, why you always daydream one? Okay, so 398. Why is it 398? Because this is the original value. The original V0 when time is 0. Right? The moment you drive out of the car, 398,000 over many years, it becomes almost scrap metal. Go close to 0. Scrap metal means that totally no price. Okay, this is the price. Okay? Is it okay? This is the graph that you will see. Joshua, shut up. Yeah. Now part 3. Part 3, they ask what happened when will the value drop to 220? Now very simple, you sub V as 220. Right? You sub V as 220. So you know that this is the graph already, right? Yeah, originally we had V0 E negative KT. Right? So in part B, we found that K was negative, was 0.022526. In C part 1, we found that V0 is 398. Right? So that's why you can see that my equation is evolving more and more. Okay? So mathematics is really like a storybook. You read chapter 1, you use chapter 1 to understand chapter 2. You use chapter 1 and 2 to understand 3. You do 1, 2, 3 to understand 4. Part 4, the frog run away. Then after that, chapter 3, what happened? The frog became a prince. Chapter 2, what happened? The prince became a frog. Okay, So you must understand, mathematics is leverage one. You can do part 1, you straight away can do part 2. Part 1, part 2 help you with 3. 1, 2, 3 help you with 4. It's like reading a storybook. Okay? Can Yes, sir. Sorry? Can. So the graph basically because, okay, you see this Salihan. You look at 398, right? 398 times e to the power of negative 0.0225 of t, right? This value here, you think of it like a. What's the value? It's a this value is about 0.9777t, right? This is like you are drawing y equals to a power x, but a is between 0 to 1. Which hand? Kiwi katan. Kiwi, left hand. Kiwi, huh? This is the left hand graph. The left hand graph is like this one. Okay, okay, no, this one. This one. Okay, this one. Okay. That's why it goes down. Boleh ya? Okay. I look at you, then you move your pen. I never look at you, you never move your pen. Jia Kai, you better wake up your idea. You don't just copy. You where's your? You go bring your. You bring your heart and your brain to school, not? Yeah. Okay, somebody asked to see this one, so I asked to. Okay. I try to put all together. Okay, like that. Okay. So there are two things. One is your brain, Jia Kai. One is your brain. One is your heart. Your brain is smart, but your heart must want to. Joshua, don't touch a female's hand. Okay, don't go and take a chance. Pretend touch. Pervert. Okay, don't touch a girl's hand. You understand or not? I can arrest you. Joshua. Yeah. Okay, good question. I'm really waiting for someone to ask me that. Yeah, okay, so Kaisen. So now, okay, so you see, okay, I believe everyone can do this, right? You sub 220, 26.3. Okay, now you got 26.3, 26.3, right? So you see, because the graph is dropping, listen. Okay, at 26 and 27, okay, at 26.3, it is somewhere here. So at 26, have I dropped to 220 yet? Haven't. Not yet. I dropped at 26.3. Clear so far? So at 26, I haven't. So the next better number is 27. At 27, then I say I reach. Clear so far? Clear, huh? So in terms of mathematics, usually you round to the safest number. Safest number. You ask yourself, right? Okay. You ask yourself, okay, because it's going downwards. So call it, there's a context, it's going downwards. When it's going downwards, 27 is the safer number that I reach. I more than 20. Okay, but if it's going upwards, call it, it's a different story. If it's going upwards, right? Then I say that 26 is here, 26.3. What happened? If it's going upwards, then you should take 26. Oh? Yeah. Okay. This one? You take the rounding off value from earlier, 398.07. Okay? Can Can I screw up? How are you? Okay. Part 3. Okay, I'm going to stay here. Okay, what happened? You playing peekaboo? Okay. Let me. Sorry. So sorry. Round, okay. So you see, I round up because, okay, you see, 26 is here. I am above 220. At 26.3, I reach 220. So if I choose 26, not quite the answer, but you know what I mean? Yeah, so if I choose 270, yes, I am 220 or less. 26.1 is still 27. I will still choose 27. Correct. But wrong. I will say at least you so I will say this okay. I will say this okay. If I want the value of the car to be 220,000, I need to wait at least 27 months. At least 27 months. If I wait 26 months, not there yet. Not there. If I wait 27 months, more already. Yeah, that's the idea. Yeah, that's what I mean. Yeah. But don't worry, we won't. Okay, I don't want to say anything. Okay. Okay, 3.4. Please try 3.4. 3.4. Please try 3.4. So when you divide both sides by log 1.04, the inequality sign does not switch. We will talk more about this in chapter 4. Okay, but it's definitely not easy. Okay, 11.98. Can. As long as you get me the correct answer. Because some people, when they got equal, right, then they thought it's 11. They're wrong. They are also supposed to be 12. As long as you can understand it's 12. Okay, then that is fine. All can? Okay, so with that, okay, you can look at your... Okay, let's look